हेलो एवरीवन, मेरा नाम है फजल। आप देख रहे हैं एमएफए सिविल इंजीनियरिंग। दिस इज अ कंटिन्यूटी ऑफ अ टॉपिक फ्लो काइनेमेटिक्स. Sub topic is stream function. It can be defined as the function of a space and the time such that the partial derivative of a stream function at any given direction give the value of the velocity component which is perpendicular to that direction. It is represented by the symbol called psi. It is used only for the two-dimensional flow. In mathematically, it is written as d psi by dx is equal to the v and d psi by dy which is equal to the minus of u. Similarly, for the case of the cylindrical polar coordinate, the relation of a radial velocity, that is a ur, is given as a 1 upon r into d psi by d theta. Similarly, the tangential velocity, that is a u theta, which is equal to the minus of d psi by dr. The continuity equation for the two-dimensional flow is given here, that is the du by dx plus dv by dy which is equal to the 0. Now putting the value of the u and the v in this equation, we got u by dx, that is u which is minus of d psi by dy plus d by dy of v, that is a d psi by dx, which is equal to 0. Now opening this bracket, it is d2 psi by dx dy plus d2 psi by dx into dy equal to 0. Now negative positive get cancelled. It means only when the psi is available there is a possible case of the fluid flow. The fluid may be a rotational or the irrotational flow. The value of the rotation in the z direction is given as a 1 upon 2 into dv by dx minus du by dy. Now putting the value of the v and the u in this equation, we got 1 upon 2 of d by dx of v means d psi by dx minus d by dy of u means minus of d psi by d minus of d psi by dy. Now it become 1 upon 2 d2 psi upon dx square minus d2 psi upon minus and minus get plus dy square, which is equal to the wz. Now for the irrotational flow, the value dz is equal to the 0. Now the equation become d2 psi upon dx square plus d2 psi upon dy square is equal to the 0. Now equipotential line, the line at which the velocity potential function is constant, then that line is called as a equipotential line. In mathematically, the equipotential function, that is a phi, which is constant. For two-dimensional steady flow, the equipotential or the potential function is a function of the two space coordinate, that is suppose x and dy. It can be written as a change in the potential function, that is a d phi upon dx into dx plus d phi upon dy into dy, which is a two space coordinate. Now from the relation of a equipotential function, d phi by dx is a minus of the u, then dx plus similarly d phi by dy is a minus of v into dy. This equation become minus of u into dx plus minus get minus v into dy, which is equal to d phi, change in the potential function. Now for the equipotential, phi is constant. Since the d phi value is equal to the 0, this equation becomes 0 is equal to minus of u into dx minus of v into dy. Shift this to the other side of the equal. Now dy into u v into dy, which is equal to the minus of u into dx. Now the dy upon dx is equal to minus of u upon v. This is the slope of the equipotential line in a fluid flow system. Now line of constant stream function, the line at which a stream function is constant. In mathematical it is written as a psi is equal to the constant. Consider two-dimensional steady flow, then the psi is a function of a two space coordinate, that is the x and y. Now the change in the stream function in the streamline can be written as a d psi upon dx into dx plus d psi upon dy into dy. We know the value of the d psi upon dx is a minus, it is a v, then dx plus d psi upon dy is a minus of u, velocity in x direction, into dy. This is equal to the v into dx plus minus become minus into u into dy, that is a d psi. Now for the line of the constant stream function, d psi is equal to the 0. The equation becomes 0 is equal to the v into dx minus u into dy. Shifting this to the other side of the equal, that is a u into dy, which is equal to the v into dx. Now dy upon dx is equal to the v upon u. This is the equation for the streamline or the constant streamline in the fluid flow system. Now flow net, the grid which is formed by the series of a potential line and the streamlines. This grid is called as a flow net. This is an important tool in analyzing of a two-dimensional irrotational flow problem. Now the relation between the stream function and the potential function. We know the relation between the velocity component x direction with respect to the potential function, that is a phi, as a u is equal to minus of d phi by dx and v is equal to the minus of d phi by dy. And also the velocity component in the form of the streamline is equal to the u minus of d psi by dy and v is equal to the d psi by dx. Now putting the value of the du of a minus d phi by dx in this equation, it is equal to the minus of d phi by dx, which is equal to the minus of d psi by dy. Minus minus get cancelled, means d phi by dx is equal to the d psi by dy. And putting the value of the v in this equation, we got that the minus of d phi by dy, which is equal to the d psi by dx. Now d phi by dy, which is equal to the minus of d psi by dx. This is a relation between the potential function and the streamline function in a two-dimensional steady flow.